9.3.3, geometric sequences and series. This will finish up the arithmetic and geometric sequences and series unit. Today we're going to be looking at finding the sum of infinite geometric series. The sum of an infinite geometric series with first term a sub 1 and common ratio r is given by the following formula. S, notice there's no sub n because n would mean that we could actually count the number of terms, and for this we can't because there are an infinite number of terms. So it is just S equals a sub 1, the first term in the sequence, divided by 1 minus the common ratio. If and only if the absolute value of r is less than 1. If the absolute value were to be greater than 1, the series would have no sum because the series would continue to increase or decrease. The geometric infinite series that we can add up using this formula are ones that each subsequent term is smaller than the previous term. So they get to a point where the terms' values are so close to 0 that adding them doesn't really have an effect. Okay, so here it is in summation notation. We want to find the sum of the infinite geometric series, which we could certainly pop into our calculator and find. We do have an infinity key on our graphing calculators. However, this is pretty easy to set up and use our formula for, which is what I would like you to do in your homework. Remember, this is just a sub 1. This is r. So using S equals a sub 1 over 1 minus r, we have 3 over 1 minus 7 tenths. That gives us 3 over 3 tenths. When we multiply by the reciprocal, we get a sum of 10. Find the sum of the infinite geometric series. So if it's written like this, they have to tell us it's infinite. And we'd have to know that we're adding up an infinite number of terms. 4 is our a sub 1 value. We can find r by putting a sub 2 over a sub 1. So negative 2 over 4, which is the same thing as negative 1/2. So our sum, using our a sub 1 over 1 minus r, is going to be equal to 4 over 1 minus a negative 1/2, which is equal to 4 divided by 3/2. And when we multiply by the reciprocal, we get 4 times 2/3, which gives us 8/3 as a total. An infinite geometric series with first term a sub 1 equaling 4 has a sum of 10. What is the common ratio? This time we're going to solve for r. So S equals a sub 1 over 1 minus r. We know the sum is 10. We know the first term is 4. What we don't know is 1 minus r. So let's clear our fraction by multiplying by 1 minus r on both sides of the equation. We distribute the 10, and we're going to have 10 minus 10r is equal to 4. Subtract 10 from both sides of the equation, and we get that negative 10r is equal to negative 6. Divide both sides by negative 10, and we have 3/5. So that is our r value. So our last example is a word problem, application problem. A ball is dropped from a height of 10 feet. Each time it hits the ground, it bounces to 80% of its previous height. Find the distance traveled by the ball. Don't forget that the distances go both ways. So let's say this is 10 feet. Here is our ball. We drop it, and it hits the ground. it is going to bounce back up to 80% of its previous height. Get that right here. That would be a little closer to scale. Not really good. Then it falls again due to gravity. And then it bounces up to 80% of that previous height. Then it falls again because of gravity, bounces back up, goes back down, goes back down, and this continues until basically it's of a height that it doesn't, measure anymore and it hits the ground. It's like just kind of rolling. So we're not forgetting the distances both ways. What that means is we have to add the down distance to the up distance. Oh, hold on, let me change that. Yeah, no, that was correct, down distance. So down distance, and then our bouncing back up distance. So we're adding all of the down movement, the one that's marked in yellow. We started at 10 for this one, so that is our a sub 1 value. And we divide that by 1 minus 0.8 because each time we are only going to be at 80% of the height we were previously as we fall. So that gives us 40. Oh, no, that one actually gives us 50 feet. 50 feet. Now our up distance, the very first time that it goes in a vertical direction up, this blue portion right here, this first bounce up after the initial drop, is going to be the a sub 1 value for the up distance. And if it bounced up 80% of what it was before, it is now at 8 feet. So the numerator for the up distance is 8. So we think about these as two different sequences, all of the downs being listed and then all of the ups being listed. So they each have their own a sub 1 value. We still have a 0.8 change in our height each time. And so we get with this 40 feet. And so our total would be the 50 plus the 40. We get 90 feet traveled total, both down and back up again by the ball before it stops.